Hello. I'm Alex. I've been working on the farm material project since the start, doing some of the soil sampling and carbon footprinting with some of the master farms here. It's been lots of fun, so thanks for that. I'm just going to go and talk about what we did for carbon footprinting, what we did soil sampling, some of the headline figures, and then I'll hand over and you can hear from the farmers who've actually done it. So, what is a carbon footprint? Essentially, we're looking at everything on the farm that is emitting carbon. So, emissions from fuel, fertiliser, and livestock, both the ruminant emissions, but also livestock feed emissions, and materials. And we compare that against things on the farm that are capturing carbon, so things like woodland, hedgerows, habitats, and soil carbon. And we try and balance the two across, and we compare them in CO2 equivalent to standardise the different greenhouse gases. So, soil sampling. We have been soil sampling 5 fields on each of the master farms and demo farms. We selected these to represent the full range of field types on the project. Soil type, permanent pasture, temporary lays, vegetable lays, arable, things like that. And we walk a W across the field, collecting soil from 15 points at 0 to 10 centimetres, 10 to 30 centimetres, 30 to 50 centimetres. And those samples get sent off to a lab and analysed for organic matter using the loss and ignition method. And at the same time, we're collecting soil bulk density to allow us to convert the organic matter into tonnes of carbon, so we can compare the tonnes of carbon on the farm against tonnes of carbon emitted from farming activities. So whilst we're doing those Ws, we are also collecting soil health measures, so soil structure, worm counts, infiltration rates, and aggregate stability, so we have an idea of how healthy the fields are over the course of the project. So what does that look like? Lots and lots of fields, lots and lots of holes, lots of pasties at our meetings. We have almost had a pasty every single day for 5 years of the project. We have definitely done a hole every single day for 5 years of the project, which is why we never leave home without our spades. We spent 159 hours of our lives watching water drain away into the fields. Between Hannah, James, Stefan and myself, we have nearly counted 10,000 worms. We have definitely dipped an auger 10,000 times, and I snapped mine. Yeah. So soil results are hot off the press, so I might need Hannah's help on this one. Hannah? Steve? Yeah.
Okay. I did actually plan to say very little today, thanks Alex. This was from 10 o'clock last night. Most of the soils have been sampled. There's still some to do because we did it. We have to sample at the same time each year. And FCT have got some additional fields to sample at end of November and December as well. So very cautiously, I present these results to you, bearing in mind that I've got a lot more statistics to do, which gives me enormous pleasure. I love spreadsheets. So what I've done is I've just picked out the key systems change. So I've looked at fields that have been started in 2021 from herbal lay, and this year they were sampled in herbal lay, permanent pasture, temporary pasture. So here you can see these fields started in arable in 2021 and finished off in arable in 2025. So as again, very speculative results, but and I can only do analysis when there was more than one field in the system. So the first part is that I do stats on it, there's no significant difference, but I've done the change in carbon across the system. So if you've got permanent pasture at the beginning of the project, it carries on permanent pasture, what's the carbon change? If it goes from herbal lay to herbal lay, what's the change? So if you look, if you're moving from herbal lay to herbal lay, the change in carbon in tonnes per hectare is per year is 3.35 tonnes increase in carbon per hectare down to the depth of sample, which is 50 centimetres. bearing in mind there's still some more fields to sample. And for temporary pasture, continuing temporary pasture, the increase in carbon is 1.3 tonnes per hectare. So we always talk about increase in carbon under herbal lays, and we can model it on the farm climate calculator, but the models that we use are an annual average based on referee papers. But the important thing here is this is data for Cornwall, this is data for your soil type. And if I can get some rigour and significance for this, this means that on your soil type, potentially, the uplift is double the predicted average across the UK. And that can be a combination of the soil type and the environment. And obviously there's a lot of variation within this, so for paddock grazing, there's an additional uplift, which is the work that's done with James Daniels and Northwick on their paddock grazing system. The permanent pasture, you see permanent pasture, there's an average drop, but bear in mind, this is not total carbon. Think permanent pasture, and I like Anthony's analogy. He talks about permanent pastures as a full cup of tea, and a slight movement, such as a change in the weather, or a slight compaction because you're forced to graze it, may drop that carbon a little bit, and you don't want to spill that tea. Is that right, Anthony?
Yeah,
yeah, okay, that's right, I'll let you tea. And then our water grass is an uplift. Anyway, this is early data, but what I'm really excited about is that the models that we use for you can be much more accurate, and it can take forward, and bear in mind the carbon data Alex is going to present is based on models, and it's always moving forward with the help of our awesome calculator team. So I'm going to stop there because this is very exciting. But I'm slightly not sleep thinking about it, so I'm going to hand over back to Alex.
Thank you. So that's the soil carbon. Carbon footprints. We have calculated averages for enterprises. There's a lot to caveat on this, and we're going to have to wait for the final report, like we're waiting for the final report from soils. So this doesn't include the soil data, because we're still waiting for some of those. It doesn't include the inventory, which is farm machinery, because the way we account for inventory emissions change from start to end of the project. So yeah, these are the horticulture, arable, beef and sheep and dairy balances at the start and end of the project on average for the farms. So it's got better, well done. A couple of things to note. Obviously, we don't have soil data because we're not with weight values, and we only soil sample about 12% of all the farmland in the project on the farms. So it's not fair for us to try and offset all the farm emissions on 12% of the farmland. One of these are also averages. Arable is tricky because all of the arable farms in the project are mixed with livestock as well, just because that's what we do in Cornwall. And the dairy has been reported in emissions per fat protein corrected milk, because that's the standardised way of reporting dairy emissions across different dairy systems. So I think there's a really good news story with dairy here. The footprint has got a lot better. I think there's about half of the dairy farms are new businesses, so they are growing their herd. We've got an extra 1,000 dairy cows in the Farm Net Zero project, but we have improved the footprint of those dairy farms. And it's also, I think, quite exciting that these new dairy businesses, as well as all the other businesses, see this kind of work as being beneficial to their farming enterprise. So, one last point to make is these are monitor farms mostly, and there's been no real obligation for the monitor farms to actively reduce their carbon footprint. But I don't know. 5 minutes, I don't have time for 5 minutes. So, 24 farms have reduced their footprint or are already net zero. How have they done that? If you think back to the carbon footprint slide I showed at the start, there have been emissions changes. So we've got 15 farms that have improved feed efficiency. That's the ratio of livestock on the farm to bought-in feed. That efficiency could be improved through feed, rotational grazing, herbal lays, which you'll hear about later. We've got 21 farms that reduce their inputs. That's fertilizer and pesticides. That again could be done by rotational grazing, double lays, making better use of slurries, and we've got 18 farms on the project to have reduced their fuel use. That's liquid, diesel, petrol, and that could be through things like your soil is healthier, so you're not working it as much, you're out wintering, so you're not driving a tractor around the yards as much. And again, you'll hear about that from farmers who are here. On the other side of the footprints, we've got sequestration. So we've got an extra 2,640 tonnes of carbon sequestered into on-farm habitats as measured using Natural England's standardised data sets for pensioner stewardship habitats. For example, we've got an extra 500 hectares of herbal ley from the start to the end of the project. We have an extra 57 kilometres of hedgerows on your farms. That's capturing an extra 500-ish tonnes of carbon. And we've got an extra 1,104 trees. A lot of that is thanks to forest reform, they don't show up in the calculator very well because they're little baby saplings, but it's a good thing that people are recognising the benefits of trees on farms, and they're putting them in now so that in the future they will be capturing carbon. So in summary, it can be done, it is being done. It is being done by the people in the room with us today. A lot of you have said that you felt lucky to have Farmers Hero. I think it's the other way around. I think we are really lucky to have farmers who want to do this work. I really do think you guys are the best in the country for innovation and collaboration, and it wouldn't have been possible without the cooperation of all you guys here. So thank you very much.